Imagine standing on a concrete wall, stretching 2.3 kilometers across. Beneath your feet lies a titan. This is the Three Gorges Dam, the largest power station on Earth. It holds back a reservoir of 39 billion cubic meters of water. To understand that magnitude, imagine the volume of 5 Loch Nesses, hovering 175 meters above sea level. This is not merely a lake. It is a massive accumulation of gravitational potential energy, suspended directly above major population centers. The Yangtze River has fueled civilization for centuries, but it also carries a history of structural devastation. This dam was built as the ultimate containment unit, a triumph of engineering, designed to regulate the flow. But in the world of catastrophic physics, there is no invincible shield. There is only probability. So, let us initialize the simulation. What happens if the concrete fractures? If the structural integrity fails? How does the map of China change? And can the infrastructure survive the kinetic impact of a falling ocean? To understand the collapse, we must first analyze the stability mechanics. This is a gravity dam. It relies not on an arch but on its own sheer mass. It is 28 million tons of concrete, gripping the bedrock. Under normal conditions, it is immovable. But nature possesses forces that ignore our engineering limits. The primary catalyst for critical failure is not an internal flaw, but an external kinetic shock. Visualize a massive landslide in the reservoir zone, triggered by bank saturation. Millions of tons of geological material impact the water upstream. This generates a displacement wave, essentially a tsunami, within a confined volume. If that surge exceeds the crest elevation, overtopping occurs. This is where fluid dynamics becomes destructive. Water cascading over the structure functions like a high-velocity abrasive agent. It scours the soil and bedrock at the base, undermining the foundation beneath the titan. Once the footing is compromised, structural integrity vanishes. The concrete wall, unable to resist the lateral hydrostatic pressure, begins to shift. This is the mechanism of collapse. It is a radical conversion of energy. For years, the dam has stored potential energy, mass held against gravity. The moment the containment breaches, that potential energy instantly transmutes into kinetic energy. 39 billion tons of water are no longer static. They are accelerating. The breach commences. The concrete barrier dissolves. We are now at minute zero. The reservoir does not merely flow. It erupts. It blasts through the gap at speeds exceeding 100 kilometers per hour. This is no longer a river. It is a shockwave of liquid mass. The sudden release generates a bore, a vertical wall of water, standing dozens of meters high. At this velocity, the fluid behaves less like a liquid and more like a solid projectile. The geography itself amplifies the destruction. The Yichang Gorge, once the dam's anchor, now functions as a hydraulic acceleration chamber. The steep cliffs constrain the flow, preventing dissipation. The energy is channeled, compressed, and focused into a singular vector of total structural erasure. 30 minutes post-breach, the wave front intersects Yichang. This is a population center of 4 million, located just 40 kilometers downstream. The evacuation window is non-existent. Sirens initiate, but the impact is immediate. The physics calculation is critical. The hydraulic momentum is sufficient to shear reinforced concrete. From its foundations, the city does not merely flood. It undergoes total scouring. Water elevation spikes by meters per second. Yichang is effectively reclassified as riverbed topography. But the destruction mechanics escalate. Downstream lies the Gezhuba Dam. This is a smaller hydroelectric station. In this scenario, it is not a regulator. It is a static obstacle. The incoming surge exceeds its load-bearing capacity by orders of magnitude. The fluid mass impacts the structure, triggering a cascade failure. Now, the current carries the wreckage of two colossal facilities. House-sized concrete fragments rotate within the flow, functioning as kinetic missiles against every bridge and levee in the disaster zone. As the surge exits the mountainous confinement, it strikes the Jingzhou Plain. This is where the geography of the disaster fundamentally shifts. The topography transitions from a high-velocity channel to a wide alluvial basin. In fluid dynamics, when a constrained jet enters an expansion, the flow decelerates, but spreads laterally. The kinetic energy is redistributed across a massive surface area. The water expands, effectively consuming the terrain. Jingzhou relies on earthen and concrete dikes designed for seasonal variance, not a total containment failure. The wave front surmounts these barriers, causing systemic structural collapse. The river reclaims its geological floodplain. Millions of acres of agricultural output are submerged under meters of high-density sediment. The silt deposition here will seal infrastructure beneath a new geological layer. The hydraulic front continues its eastern trajectory. Velocity stabilizes at approximately 30 km per hour. But the mass is relentless. It is a slow-moving, high-pressure event. 24 hours post-breach, the vanguard intersects Wuhan. This is a megacity of 11 million. A critical logistical hub, situated at the confluence of the Yangtze and Han rivers. The elevation is critically low. The floodwaters here encounter the friction of urban density, generating complex, turbulent currents through the city grid. In the simulation, water levels in Wuhan breach the third-story elevation. The primary vector of danger shifts from kinetic impact to environmental biohazard. The torrent scours industrial zones, mobilizing chemical stockpiles and biological waste systems. The fluid composition alters into a hazardous chemical suspension. Furthermore, the structural mechanics turn critical. The hydrostatic pressure on foundations, combined with soil liquefaction, compromises the friction piles holding up the skyline. Skyscrapers risk total vertical failure due to loss of ground stability. Beyond the urban core, the channel broadens. Velocity decays, but volumetric mass persists. The surge inundates the basin lakes of Jiangxi and Anhui. Poyang Lake, the regional hydraulic buffer, reaches maximum capacity and ruptures its bounds, merging with the Yangtze. This creates a temporary inland sea. The cartography effectively regresses millennia, with vast wetlands erasing provincial borders. Finally, the wavefront intersects Nanjing and the Shanghai Delta. The kinetic violence subsides into a hydrostatic siege. It is no longer a projectile. It is a rising, relentless inundation. Shanghai, built on alluvial silt, faces a dual threat. The massive freshwater discharge from the rear collides with oceanic tidal pressure. The city faces systemic paralysis. The resulting discharge into the East China Sea would be observable from orbit. A massive sediment plume extending hundreds of kilometers, transporting the geological and structural debris of the interior. The societal impact of such an event defies calculation. We are analyzing the forced relocation of tens of millions of individuals. The global logistical networks would suffer immediate systemic shock. But we must shift focus to constructive resilience. We simulate this worst-case scenario not to induce panic, but to engineer prevention. This is where the survival protocol initiates. How do we guarantee structural permanence? The primary defense is data acquisition. The Three Gorges Dam operates as one of the most instrumented structures on the planetary surface. It is encased in a digital nervous system of thousands of sensors, quantifying stress loads, deformation, and hydraulic seepage. Orbital synthetic aperture radar measures millimeter-level geological shifts in the surrounding terrain, predicting slope failures before gravity takes hold. Survival is a function of information. The secondary layer is mechanical redundancy. The facility is equipped with high-capacity sluice gates and spillways, designed for rapid hydraulic discharge. Upon detection of an incoming surge or geological instability, operators initiate a preemptive drawdown. This creates a volumetric buffer to absorb the shock. This is the art of managing potential energy before it transitions into a destructive kinetic force. For the population downstream, survival hinges on the strategic classification of terrain. The state employs designated flood diversion zones. These are specific topographic basins, legally allocated for controlled inundation, to preserve high-value urban centers. If hydraulic pressure exceeds critical limits, controlled demolition charges fracture the levees. In low-density agricultural sectors, this diverts the fluid mass out of the main channel. It is a utilitarian calculation, exchanging agricultural output to secure the structural integrity of the Wuhan metropolis. On an individual level, survival in a mega-disaster is a function of verticality and data. Understanding regional topography is non-negotiable. In a breach scenario, geological depressions become zones of zero survivability. Safety exists solely on the ridge lines. So, what is the data we extract from this simulation? The Three Gorges Dam illustrates the paradox of scale. We construct these titans to generate clean energy and regulate the periodic hydrological cycles that have historically decimated populations. The structure has successfully mitigated countless flood events. It is a statistical net positive for civilization. However, concentrating this magnitude of power creates a single point of failure. The lesson is that we must respect the potential energy we stockpile. We cannot merely build. We must maintain with the same rigor applied to strategic weapon systems, because that is the energy yield we are containing. The geography is defined by its hydrology. Humanity has modified that map with reinforced concrete. But gravity is a constant force, seeking equilibrium. It waits for a structural deviation. Our mandate is to utilize physics, interferometry, and engineering to ensure gravity never achieves that conversion, to decode the chaos and survive with science. Maintain your connection to Surphysia.